Okay, so this lesson's all about end model behavior. And if we look at these graphs and compare them to the equations, what do you notice? We've talked quite a bit about degree 2 is a parabola. Now, notice this parabola, both sides are going up. This parabola, both sides are going down. All even graphs either both go up or both go down. And they go down if it's negative, and they go up if the leading coefficient is positive. We've talked about x to the third is this little wiggle where the left side always goes down, the right side always goes up. So does it make sense if an odd degree is negative, the left side goes up, and the right side goes down? It's reflected over the x. So let's think about some things that have to do with end model behavior. So the x-axis goes left and right. Does it make sense? If I go to the left, I'm going in a negative direction towards negative infinity. If I go to the right on the x-axis, it's a positive direction going towards positive infinity. If we go down on the y, that's going in the negative direction. If we go up on the y, it's going in a positive direction. So where that might make sense, the notation tends to confuse people just a little. So we read this with this arrow, as x approaches negative infinity, that just means to the left. As x approaches positive infinity, that just means to the right, because x goes left or right. Y approaches infinity just means it's going up, and y approaches negative infinity just means it's going down. So it's on the left side, what is it doing? Is it going up or is it going down? And on the right side, is it going up or is it going down? So we're always going to use these two every time and talk about what the ends of the graph are doing. So everything's dependent on the degree, which makes the shape, and the leading coefficient, if it's positive or negative. So if we look at the first example, the graph we can tell is an even graph. And I always talk about 1, 2, 3, 4 directions, degree 4. And since both sides are going down, it's a negative leading coefficient. So for end behavior, this is the new part, this is the harder part. We say as x approaches negative infinity, y approaches what? As x approaches positive infinity, y approaches what? So let's think about, let me translate this. What did we just write down? That as x approaches negative infinity just means to the left. If I trace the left side of the graph, which way is it pointing? Down to negative infinity. Down just means negative infinity. So as we trace the right side of the graph, which way is it pointing? It's also pointing down to negative infinity. So when you see this, it just means the left side. When you see this, it just means the right side. You're just going to say, is it pointing down or is it pointing up? In this case, both were pointing down. Example 2. One direction, so the degree is 1. The leading coefficient, see how this is a positive slope? The left's going down, the right's going up. This is a positive leading coefficient. End behavior is just as x goes to the left to negative infinity, y is doing what? As x approaches positive infinity, goes to the right, y is doing what? See, this is kind of a template for every single end behavior model. So just write this down all the time, and then we just look. The left side, this is going down to negative. So that means the graph y is pointing down to the negative side. What is the right side doing? Pointing up to positive infinity. So y goes up to positive. The left side goes down, the right side goes up. So how do we do that if we're not looking at a graph? We analyze the equation. Everything comes from the degree term, though. So the degree, the highest exponent, is 3. The leading coefficient, and the number right now is not as important. We just want to know, is it a positive or negative leading coefficient? So degree 3 with a positive leading coefficient just gives us that sketch for the graph. So then we can go into end behavior. As x approaches negative infinity, y approaches, and if we just write this out every time, as x approaches positive infinity to the right, y approaches, this part never changes. Then we just look at the graph. The left side is going down, the right side is pointing up. And that's it. So let's look at this one. Everything comes from the degree term. The degree again is 3, but this time my leading coefficient is negative. That just means the graph goes like this. It starts from the top left and goes down. So how does that change end behavior? So always start the same. As x approaches negative infinity, y approaches what? As x approaches positive infinity, y approaches what? All right, so then we look at the graph. The left side is pointing up to negative, or up to positive infinity. The right side is pointing down to negative. So that's why we look at the degree, we see if the leading coefficient is positive or negative, sketch a graph, and look at the graph. Just be kind of careful, because the degree is not always the very first term. The degree is the highest exponent. So in this case, the degree is 4, and the leading coefficient is negative. The leading coefficient is not always the first part. It's always connected to the degree. So degree 4 leading coefficient negative means it's going down. And it kind of makes that M shape where both sides are going down. So for our end behavior, as x approaches negative infinity, y approaches what? As x approaches positive infinity, y approaches what? So the left side is pointing down to negative infinity. The right side is also pointing down to negative infinity. So everything hinges on the degree and the leading coefficient.